right, let me get my screen ready to pull this up. But yeah, if your camera's off, I don't know if you're in class or not. But especially if class ends and you don't go away to your next class or anything, quite obviously you're not in class. So anyway, you guys doing good? Got your cameras on? Almost everybody. I'll keep my eye on it. But let's put up our screen to see what we're looking at this week. See, last week, what did we do? We did geometric sequences, right? We've done arithmetic sequences. We've done arithmetic series. We've done geometric sequences, which kind of tells us this week we're going to be looking at geometric series. Yes, geometric series this week. Then next week, we have graphing sequences and series. We can do both those in the same one lesson. And then the test the week after. So the week of Valentine's Day, we're going to finish up our first module and test. We have a practice test for us as well. And then parts 1 and part 2 of the test. So that's what we have. Geometric series today and then graphing next week. So just 2 lessons left in module 5. Let's switch over and take a look at the lesson then. Geometric series lesson. Did make it to a movie this weekend. What did I see? It was a movie about a teacher that helps a student. And this is a true story, one of those things. A student that has all kinds of problems. He's an orphan. Been raised in orphanages and stuff. And now he's living in his car in high school. And his teacher kind of takes him into his house so he has somewhere to live. I don't know. It was pretty good. Face the Dark, I think was the name of the movie. But it was pretty good. All right. Oh, we got a little video. And it looks like one of them little goofy cartoons that they like to do here. So I'll share that properly. One of these little goofy cartoon movies. Some of their cartoons are kind of funny. Just kind of crack me up. I don't know if they're supposed to, but yeah, I find them kind of entertaining in a humorous way. 2 minutes, 41 seconds. Let's see what they're going to start us out with here with these geometric series and this little fun video.
Rachel's mother just returned from a vacation to Moscow. She brought back a set of matryoshka, or nesting dolls, for Rachel. Nesting dolls are a series of dolls that open up so that each doll contains a smaller doll until you get to the smallest, innermost doll. The packaging that came with the dolls notes that there are 8 dolls and each doll is 10% smaller than the previous one. Rachel has a 2-foot-long shelf in her room, but it's covered in small dolls already. She doesn't want to clear it unless she knows the nesting dolls will fit. First, she measures the largest doll. At its widest, it is 5 inches long. Rachel does not want to find 90% of 5 inches, then 90% of that number, and so on 8 times over. So instead, she uses a special way of adding numbers that change by a constant percent. The first doll is 5 inches wide. The next doll is 5 inches times 0.9 because it is 10% smaller. The next doll is 5 inches times 0.9 squared because it is 10% smaller than the previous doll. Rachel can find all of the doll's widths this way. She knows that when a number is multiplied repeatedly by the same constant, the sequence of products is called a geometric sequence. In this lesson, you will see how to add terms quickly in a geometric sequence. This sum is called a geometric series. You can use it to see if the nesting dolls will fit on Rachel's shelf. You find the sum of a geometric series using the formula S sub n equals a sub 1 minus a sub n times r all over 1 minus r. S sub n is the sum up to the nth term. In this case, you want 8 terms added. A sub 1 is the first term, and a sub n is the last term. So here, a sub 1 is 5, and a sub n is 5 times 0.9 to the 7th power. R stands for the common ratio, and is the factor that each term is multiplied by. In this case, r is 0.9. So substitute and solve. The dolls will span about 28.5 inches, or just over 2 feet and 4 inches. Rachel's 2-foot shelf is not enough.
Okay. So I like this, Rachel. She likes math so much, she's using math to figure this out. When I would have just laid them out on the table and measured how long they are. Or I would have taken the fact that some of them are really small and I would put them in front of the ones that are really, other small. And I would have got them all on 2 feet. But she's very, very picky and wants them lined up perfectly and doesn't want any in front of each other because you could kind of put them forward and backward a little bit and easily fit that extra 4.5 inches. But she's a math girl, apparently. So your knowledge of geometric sequence, is what we looked at last week, would help you find out how wide the last Matryoshka doll is, not the total length. So geometric series. So we're going to learn how the geometric sequences and series differ and what important information must be included to find the sum of the geometric series. And they gave us a little preview of the formula as well. So we'll be adding that to our notes here in just a moment. All right, a geometric series, similar to a arithmetic series, is the sum. We add all the terms up, the sum of the terms of the sequence. But they are separated by a common ratio instead of a common difference, right? Because that's multiplying times a certain number. So just like we've been doing, we're going to see, I'm going to turn on the chat. Yeah, and then you can just put them inside each other and just stack them in one doll up there. Yeah, anyway. Some of these are geometric sequences, some are series. So I'm gonna make this bigger and we're gonna go through this in our chat like we did before. So I can go up one more. Yes, there we go. Okay, so is this a sequence or is this a series? They're both geometric. So remember, last week we looked at a geometric sequence. And a series, we add them all up. So we have 1, 5, 25, ... That comma is a big hint on whether or not this is a sequence or a series. Shay's on top of it quickly. What is this, sequence or series, folks? Come on, I know the rest of you are not sleeping. All right, Madison agrees. Agrees this is a sequence, not a series. Anyone else think? Yes, I said that in a minute. All right, sequence. I'm seeing some sequence, folks. And it took it, so that must be right. How about 4, -32, +256? Sequence or series? There's not an other. So it is one or the other. It is geometric. It's multiplying by -8 each time. 4 times -8, -32 times -8 is +256. Is this a sequence or is this a series? Oh, we're thinking series. Let's see. No, it won't let me put it as a series. No, these are still just a comma. It's a sequence. Look at this. This looks a little different, right? 3 plus 6 plus 12. Yeah, this is a series. A series, we're adding them all up. This is a times 2 ratio. About 9 minus 27 plus 81. Don't let that fool you. Yeah, that is still just a series. We're adding a -27. 9 plus a -27 plus 81. You know, it shows up when you add a negative, it's the same as subtracting. So good job. Geometric sequences are separated by commas, where series are being added. So multiplication, addition sign. So. All right. Oh, and we're going to do a matching, so I'm going to leave it big here for a minute. Now that you're able to distinguish between the sequence and the series, let's discover how the sum of a geometric series, how to find it without having to add each one to the next one. Because if we had to do 48 terms, it would take us a while. So we're going to find a formula that's going to work with every finite geometric series. So let's refresh what the terms mean right here. So Match each variable to its corresponding definition. A sub n. A sub n. Let's just number these 1 to 5 to make this easy so you don't have to type a paragraph here. Across the top is number 1, 2, 3. The bottom is 4 and 5. So A sub n, which one of these is that? Is that the first number in the sequence? Is that the common ratio between the terms? Is that the sum total of numbers in the sequence? Is that the number of terms in the sequence? Or is that the value of the nth term in the sequence? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm seeing a couple of fives. People think it's the value of the nth term. Anyone agree with that, or you think it's different? A sub n. A sub n. Yeah, A sub n is the nth term. So if that was the 9th term, that'd be A sub 9, whatever. That is that. Okay, A sub 1. Oh, this one we know. Yeah, that shouldn't take long there. Yeah, I'm seeing ones pop up real quick. Yeah, that's the first number. A sub 1 is the first number in the sequence. What about n? Just the n. Just an n, not an A sub n, just n. 1, 2, 3, 4, 5. 1 and 5 are already taken, so it's 2, 3, or 4. Shay says it's 4, the number of terms. The number of terms of the sequence is n. All right? Anyone else think that's right, or do they think it's something different? You think it's the common ratio? You think it's the sum total? Shay's on top of it. Shay, you're going to do well this assignment. R, what is R? Yeah, 2. Jonathan's got it quickly. 2. That's the common ratio. Remember, it was D with arithmetic because it was common difference. And so that leaves this last one as S sub n. S sub n will be the sum total. That's what we get when we add them all together. The sum total. So great job. We've done some good matching here. Bring that back down. Let's move on down. So now let's find the formula for finding the sum. So if we look at this sequence, S sub 6 equals 3 plus 6 plus 12 plus 24 plus 48 plus 96. So what's the first term? Well, we can see that right there. That's a 3, right? 3 is the first term. What is the common ratio? What's happening here? I'll make this a little bigger because it could probably help. 3 plus 6 plus 12 plus 12. The common ratio, what's happening every time? 3 to 6 to 12 to 24. That's times 2, right? Common ratio of the series is 2, which we can find by dividing backwards. 24 divided by 12 is 2. 12 divided by 6 is 2. 6 divided by 3 is 2. So what is the sum of the series? Well, we can just add those up. 3 plus 6, that's 9. 21. 21 plus 24 is 45. 45 plus 48 is 93. 93 plus 96 is 189. Just adding them up. They're all listed there. So finding the sum is very simple. There's just 6 terms, 1, 2, 3, 4, 5, 6, and each of them are relatively small and they're nice integers. So that's not bad. But if we want to have a formula, in case we have like some weird common ratio of 7/8 or something, right? And we have 81 terms. We need a formula to do that instead of adding up all 81 terms. So, all right, let me got another video here that's going to help us come up with this formula. And it is 2 minutes and 11 seconds long. Let's take a look and see what it shows us here. Come on, quit dodging me. Okay, I'm not hearing anything either. Just letting you guys know. I don't think there's any sound in this. All right, so let's go through it together then, since they're not going to give us any sound. So I'll start it over. First term is a 3. So factor 3 out of each term. So 3 times 3 times 2, 3 times 4, 3 times 8, 3 times 16, 3 times 32. So 3 is being multiplied by this common ratio. The common ratio was 2. Every time we multiply by 2. So we rewrite this now. That's 2, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. We see each time it's just another 2 being multiplied to get each term. So now doing that, each term we need to be written using variables. So let's replace the 3's with A1 and R's, the 2 with R's. So now we have this formula. Yeah, I'm going to pause it real quick. So we see it's A1 and then A1 times R, and then A1 times R squared, and then A1 times R to the third, R to the fourth, R to the fifth. So this is now multiply both sides by the common ratio. So when they do that, they're going to multiply the left side by R, and then all the terms on the right side have to be multiplied by R to keep it equal. So you see now on the left, we've got that R added there. And then on the right side, the first term is A1 times R now. And the second term is now R squared, and then R third, and R to the fourth, so on and so forth. To where if we got all the way to R to the sixth at the end. So we've got sum of 6R, and then all of the terms have been added one. Now we're going to subtract the bottom line from the top line. So that means you need to distribute that negative to all the terms on the bottom line, because it was plus, plus, plus. But if we're subtracting it, now we're going to subtract each one of those. So you got to remember that and to distribute that among all of those. Now, what's interesting is you've got an A1R on the top and the bottom, so they cancel out. And an A1R squared, A1R third, and they cancel each other as you go about it. So on the left side, you have the S of 6 minus S of 6R, but on the right, all you have left is the first and last terms because all the others canceled out in between there. So A1 minus A1 times R to the sixth. They're working hard to get this equation here. So you have the sum minus the sum times R. So they factor out the sum total, times 1 minus R equals the first term minus A1 times the R to the sixth, which there were 6 terms. So to get the sum, you divide both sides by 1 minus R. And that gives us what our formula will be. So we'll put this on paper and put this in our notes here. Okay, well, this equation may work for the geometric series S sum 6 equals 3 plus 6 plus 12 plus 10. Because that's 6 terms. It won't work for a series with fewer than 6 terms or more than 6 terms because this is S of 6 and this is R to the 6. So we just change that to an end where it'll work for any series. There it is. S of n, however many number of terms, equals the first term minus the first term times R to the n divided by 1 over R. So this is going to take a little more practice using this. All right. So now we know how to find the sum of geometric series. Well, we're going to have to practice with this to prove to ourselves that it actually works. So let's put this in our notes. So I've got this written down just to get our notes started. S sub n equals A1 minus A sub n R over 1 minus R. And I think we should take us a geometric series and just check to see if this actually works. Because right now, I don't think we're convinced because that seems like a lot of fancy math just to come up with a weird looking formula. So let's start with a sequence that multiplies by 3 and our first term is 2. So 2 times 3 is 6. 6 times 3 is 18, 54, and 162. Let's go ahead and do one more term. 486. So multiplying by 3 each time. All right, let me know if I messed that up. I think that should be correct. 2 times 3 times 3 times 3 times 3 times 3. So we have 6 terms. And if we want to know what they are added up, Our formula says, oh, well, I guess that's not really, man, what did I do with my ratio? There it is. It's not going to be S sub n. This is going to be S sub 6 because there's 6 terms. It says we take our first term, which is 2, and subtract from it 2 times our common ratio. I'm not 2, A sub n. 486 is A sub n, which is A sub 6. 486. Oh, didn't put a 6 in there. Times the common ratio of 3. And we're dividing that by 1 minus the common ratio. 1 minus 3. Okay, let's get our calculator and see what that puts us at by when we do the math here. So 2 minus 486 times 3. Let's see what 486 times 3 is. 486 times 3. So this is 1,458. So 2 minus 1,458 is negative 1,456 divided by 1 minus 3 is negative 2. So it says the total of all these added up, divide that by negative 2, is 728. So what is it if we add all those together? Let's actually just do that. All right, 2 plus 6 plus 18 plus 54 plus 162 plus 486. Hey, that actually works. So this weird looking formula right here, S sub n equals the first term minus the last term times the common ratio divided by 1 minus the common ratio, actually came up with the correct total for adding those 6 terms of that geometric sequence. Interesting. I'll leave it up for a second in case you're putting that in your notes, but just needed to test it. We had to prove that it actually would come up with an actual correct answer. Certainly appears that it does. We'll be practicing some more here, but I want to get that first one there just to prove to ourselves that really is a formula for a geometric series. Okay, let's go back to our lesson. All right, let's go to page 2. When given a geometric sequence with a set number of terms, it is possible to use the geometric series formulas to find them. Formulas. Oh, they've only given us one formula so far. So is there another one? All right. Example number 1. Find the sum of a geometric series 5, negative 15, 45 if there are 11 terms. So we should try this on our papers just so we have more notes. Just to try this out. So 5, negative 15, 45, 11 terms. And the water is contaminated a couple different ways. One is okay. Oh, wait a minute. Did I put our formula down differently? I think they have a different formula now. Wait a minute. They're using a different formula what they gave us here. Because this formula, I think this must be, yeah, this is the formula. Oh, A1 R to the 6th. Oh, I wrote down a different formula. I wrote down the formula. I wrote the recursive formula down. They come up with this one. I wrote the formula they gave us in this video up here. So let's write down their new formula as well. This is the recursive. This is if we know the last term. This is a different formula they gave us in this last video. So I need to get, this is important. This is A sub n. If we know the last term. Let me hold on for this for a second. If we don't know the last term, A sub 1 minus a sub 1 times r to the n 1 minus r. This is the one they gave us in that last video. And notice the difference here. A sub 1 r to the n, where this one's just a sub n and r. So if we know the last term, we use this one. If we don't know the last term, we use this one, r sub r to the n power times a sub 1. So for this one, 5, negative 15, 45. So just to highlight our two different formulas. That's why they said we have formulas, because they gave us two, and I didn't catch that we had a different one in the second video than the first video. With this one, and they want to know 11 terms, you got to figure out which formula would you use on that. Well, this one, for the sum of the 11 terms, I have to know what the 11th term is. A sub n times r. Oh, I don't know what the 11th term is. I only know the first three. I could calculate it, but that would be a bit of work because I've only got three. I got to figure 4, 5, 6, 7, 8, 9, 10, 11. But this one, I don't have to know the 11th term. So let's try this formula. So the sum of the first 11 terms would be the first term, 5, minus the first term, 5, times r to the n. What is the r? Negative 15 divided by 5 is negative 3. 45 divided by negative 15 is negative 3. This is negative 3 to the 11th power. 1 minus negative 3. Okay, let's simplify by getting our calculator out here again. Officials suspect that these oysters were contaminated and 5 minus 5 times negative 3. So let's write, so that would be 5 minus 5. And let's find out what negative 3 to the 11th power is. Raised to the power of 11. So that is negative 177,147. Move our calculator over here again. Over 1 minus negative 3 is 4. All right, so this times negative 5 times negative 5. And that makes it a positive, so add 5 to that, plus 5. So this equals 8, 5, 7, 40 divided by 4. But let's verify our math on that. So 5 minus 5 times, I'm putting in parentheses, 177,147 minus, close the parentheses. Yes, that's 885 740, and then divide by 4. So adding up the first 11 terms, it's 221,435. Adding up all the first 11 terms of this sequence. Let's check to see what they got and see if we're right. 221,435. Page 2. 221,435. Okay, that is the sum of the first 11 terms using the second formula. Go to example 2. Find the sum of an 8 term if the first term is 7 and the last term. So this time we know the first and last term. So let's do it on paper first, and then we'll verify it with their video to see if they get the same answer. Oh, well, actually, we don't have R on either one. So let's see if we can do this before we watch their video. We know the first term, we know the last term. This one, we only have to know the first term and the common ratio. This one has the first term, the last term, and the common ratio. But we don't have the common ratio to use either one. So we have to find the common ratio first before we can find the first 8 terms added up. So that means we're going to need to start with this one because we have the first term and the last term, and R is the only unknown. So let's substitute what we know. Oh, we don't know the total either, though. Since we don't have the series total, we got to go back to our geometric sequence formulas that we used last week. We know that the 8th term is 114,688. And we know the first term is 7. And 7 is being multiplied by r to the n minus 1. N is 8. So that's r to the 7th power. So if we divide both sides by 7, yeah, this goes back to last week's work here. Okay, let's clear that. 114,688 divided by 7. So it's 16,384 equals r to the 7th. Then we got to take the 7th root of both sides. The 7th root of r to the 7th is just r. What is the 7th root of 16,384? So let me shift and that lets me choose right here which root I want. I want the 7th root. So that's 4. That's 4 to the 7th power is 16,384. So now we have our common ratio. R equals 4. So now we can look at our two formulas. And we could technically use either one of them. But since we have the last number, let's use this one. S sub 8, because there's 8 terms, equals the first term minus the 8th term. 114,688 times 4 comes common ratio 4 divided by 1 minus the ratio 1 minus 4. So the sum of the first 8 terms, 7 minus 114,688 times 4. Move that up since we've through with our formula there. This on this side. 7 minus, and I'll put this in parentheses where I multiply these two together. 114,688 times 4, and then close the parentheses. It's this negative 458,745 divided by negative 3, right? 1 minus 4 is negative 3. So let's divide this by negative 3. Negative 3. So the sum of the first 8 terms would be 152,000. I don't think that's right. Not if the 8th term is 114,688. Have we got something wrong somewhere?
You gotta pick which one you were going to work on. You're going to go do the
Well, we're going to watch their video and find out, see if we did something wrong. Let's try it with the other formula just to see if we get the same answer. If so, that might be right. So if we try with the other formula, sum of the first 8 terms be the first term 7 minus 7 to the 4 to the 8th, right? 4 to the 8th term over 1 minus 4. That's using the second formula where we use the first term both times. Let's see what that gets. So 7 minus 7 times 4 to the 8th power. Let's take 4 to the 8th power. That times 7. Okay, so this is 7 minus 458,752 over negative 3. Maybe this can be right. So let's see. 7 minus 458,752. Okay, that's the same number we got here. And divide it by negative 3. Same answer. All right, I guess that's what's going to be, because that's an awful big number for the eighth one. But I guess if you divide it by 4, we're to add 25,000. I guess we're going to get the same answer either way. This is still 152,915. So using either formula, we come up with the exact same answer. Let's see what they get. 152,000.
First, define each variable. There are 8 terms in the sequence, so n equals 8. The first term is 7, making a sub 1 equal to 7. Finally, the last term is 114,688. Use this number for a sub n. Simplify. Now that you know the value of the common ratio, you may use either formula to find the sum of the series. However, to ensure that you have practice working with both formulas, let's use the formula S sub n equals a sub 1 minus a sub n times r all over 1 minus r. The sum of an 8-term geometric sequence, if the first term is 7 and the last term is 114,688, is 152,915.
And there's our answer. That's what we had. Lovely. And it says you could do that with either formula. Okay, now my video doesn't want to shrink down, so let me reload this. Okay, and that was example 2. And we did come up with the right answer. 152,915 is the sum of the 8-term geometric sequence. Let's look at example 3. Some research states that viewership for the Summer Olympics increases 22% every 4 years. If there were 1.5 million viewers in 1980 and the percentage stays consistent, how many million viewers were there between and including 1980 to 2008? So add it up. Okay, there was 1.5 million in 1980. How many were in 84? Add that. How many were in 88? Add that. 92, et cetera, et cetera, et cetera. Round to the nearest tenth. So answer the following questions according to direction given. Select your answer, submit. So first we determine which series we want to use. So would we use A1 minus A1 R to the N, or 1 minus R, or A1 minus A sub N R? Well, 2008 was the last year. They did not give us the number for the last year. We don't have A sub 2008. How many terms? Let's see, 1980, 84, 88, 92, 96, 2000, 2004. So that's 8. There's 8 different Olympics that we're adding up. So we're going to use the one that just uses the first one, A1, R sub N. Because we know R and A1, so we'll use the first one. Excellent. Since we don't know how many viewers in 2008, but we do know A sub 1, and we know the percentage. Okay, what's the next thing here? Let's see. Match each variable to the value on the right. So for our problem, A sub 1 would be the 1.5 million for the first year, right? R would be the common ratio, 22% increase each year, right? 22 increases by 22%. And the number of Olympics are 8. And that was it. There's only 2 of those. This is before you apply the formula. A small change must be made. Yes, because the ratio is at 0.22. So if we just put 0.22 in, that means we only had 22% of what we had last time. So since it's growing, instead of this formula, that's a good point. Let's put this in our notes. In this case, since 1.5 million for what was it, 1980, 1.5 million, 22% increase. So we don't want to use A1 minus A1R to the end. We don't want to just use the R because that would be 0.22. That wouldn't be an increase. That means there's only 0.22 left. We'd have to use A sub 1 minus A sub 1, 1 plus R to the end. We'd want 1.22 because that means we still have what we started with and we added another 22%. And if we make that 1 plus R, we also have to do 1 minus 1 plus R on the bottom. So we're modifying the formula a little bit for this real life, talking about increase or decrease. If it's a decrease, we'd take 1 minus R, but it's an increase, so we'll do plus 1.22%. And that's what it's saying on this page right here, 1 plus R. This change will only be made when the common ratio is a percentage. For percentage increases, 1 will be added to each. For decreases, you're subtracting from 1 minus. So now we can apply the geometric series formula. So enter the correct value to the nearest tenth. How many million? Okay, so let's apply our formula now. So this was the original formula. So using this formula, we're going to say S sub 8 equals 1.5 minus 1.5 times 1.22 to the 8th. 1 minus 1 plus 0.22. So on the bottom will just be 0.22 because 1 minus 1 will cancel out. So S of 8 equals 1.5 minus, let's see what all that comes out to be. 1.5 minus 1.5 times, so I'll put it in parentheses, 1.22 to the 8th. 1.22 raised to the 8th power. Excuse me. 1.22 raised to the 8th power, close parentheses. So this all equals negative 5.86. I'll do 156. I'll take it away still. And 0.22 on the bottom. Right? Because 1 minus 1 plus 0.22. So if we divide this by 0.22, so there were about 26, what they say around that to the nearest 10th, 100th, nearest 10th. 26.6 million viewers for the 2008 Olympics then. All right, let's see if we got that. Now, around to the nearest 10th, 26.6. Excellent. There you go. There must have been something more on TVs. We're using our formula. Applications. So Sebastian purchased a mega bouncy ball. Oh, love the mega bouncy ball. That claims that it bounces back up to 83% of its original height. So if you drop it from 100 inches, it'll bounce back up to 83 inches. That's a pretty good super mega bouncy ball. So Sebastian sets up a yardstick and he drops the ball from 3 feet and he's put his data here below. So each time the ball was on its way down is considered a fall. So first time he dropped it from 3 feet and it bounced back up to 2.49 feet and then it fell. And then it bounced back up to 2.07 feet and then 1.72 feet. And he let it fall 12 more times. Now it gets hard to measure that accurately. To calculate the total distance, we're going to use a geometric series. Total distance, 3 plus 2.49 plus 2.07 plus 1.72. Because he knows the first term was 3. That's where he dropped it. The common ratio is 83.83, 83%. He's using the A1 minus A1RN, where n to be a total of 16 falls, because it listed 4 falls right here, and then he said 12 more, so 16 total. So substitute the information he knows. A sub 1 was 3, so that's how he dropped that. 83 was the percent that it has the second time. 16 is the number of drops. 1 minus R. So 3 minus 3.03, 16. To simplify, the 1 minus R is just 0.17 on the denominator. 0.83 to the 16th power is 0.051. Multiply it times 3. And then finally get 2.848 divided by that, 0.17. So it fell a total of 16.75 feet over 16 bounces, adding each bounce up to the other. And example 5, a popular smartphone app increased the amount of points to reach the next level, and each level the points needed to move on doubles. You got to have twice as many points to get to the next level every time. So the first level you need 5 points, and then the second level you need 10 points, and the third level you need 20, and then you need 40, then you need 80, and you need 160, 320 to get to the 7th level. And he wants to know how many points total, if I just want to make it to level 7, how many points do I need altogether? Because after I get my 5 points, then I have to get 10 more points to get to the second level. So he can use either series, because he knows what the 7th one is, or he can use this one with just the first one. 5 minus 5, it doubles each time for 7 levels, 1 minus 2. Or he knows the 7th level requires 320 points, and the common ratio is 2. So either way, 635 points are going to be needed to go from level 0 to level 7. Take a look at the lesson summary here, since we're playing the exact same video. Let's see. How do geometric sequences and series differ? What important information? So here are the 2 geometric series formulas. That's what you really need in your notes. That's really the only thing we need. As long as you know what R is, A sub n is, S sub n, A1, and n. So A1 minus A1 R to the n over 1 minus R, which was our first formula we had. Oh, that was the second formula I had written down. And then A1 minus A sub n R over 1 minus R. So as long as you have those 2 formulas, you should be able to do geometric series rather simply. Let's see, they got several pages of practice. We can look at a little bit of it since we have some time. Match the term on the left with the appropriate term on the right. Oh, this is good, because this gives us all 4 things we looked at: arithmetic sequence, arithmetic series, geometric sequence, geometric series. So let me make this bigger. And this is a nice review. So notice 2 of these formulas have A sub n, and 2 of them have S sub n. Right? The S sub n are always going to deal with series. That's when we take the sum, and this is the sum of that many terms. The sequence, we have the A sub n, where if we want to know a specific term, what is the 38th term in a sequence, we use the A sub 38. So arithmetic sequence. An arithmetic sequence, we know is going to be an A, because this is not adding them together. So is it going to be the first one or the second one? The first one is the A sub 1 plus n minus 1 times D. The second one is A sub n equals A sub 1 R to the n minus 1. Well, the easiest way to pay attention to that is, what do arithmetics use? Common ratios or common differences? Arithmetic is differences, right? It adds the same number. So you're looking for the formula that has a D in it. Got to be this first one, the D. So the other one that has a D in it, oh, there's not another one with a D in it. So we'll come back to that. So the other sequence, geometric sequence, would be A sub n, is this one that has the R in it. And then you got arithmetic series and geometric series. This is where we add them all together. The sum is either A1 minus A1 R to the n of 1 minus R, or the number of terms divided by 2 times the first and last term added together. That was the arithmetic first and last term added together times n minus 2 geometric series. All right. Match each sequence or series described with the formula that's used to evaluate it. Oh, this is good. I'm gonna put this in the chat. So this is class participation time, because this is very useful for us to understand. If we want to define the, and this will be numbered 1 to 6. So give me your choice: 1, 2, 3, 4, 5, 6. If we want to find the sixth term of the sequence 2, 12, 22, and we want to know what the sixth term is, which one of these formulas can we use to find that? The sixth term. Do we want 1, 2, 3, 4, 5, or 6? Now I'll tell you, if you're paying attention, you can eliminate 4 of the choices immediately. 4 of those choices you can automatically eliminate and bring it down to 2 choices. One, 2, 3, 4, 5, or 6. I want to find the sixth term of 2, 12, 22. I'll wait while you look at those. I wonder if I can make them any bigger than that at all, because no, it changed it to text when I made it bigger. So, all right, that's as big as it's going to get then, guys. So hopefully you got a good high-speed connection that's clear. If your connection is lagging and you got kind of a low resolution connection because your internet speed is too slow for it to make it clear for you, which, sorry, nothing we can do about that. But find the sixth term of 2, 12, 22. So the first thing you got to figure out, is this arithmetic or is it geometric, right? 2, 12, 22. Oh, obviously that's arithmetic. It's just adding 10 every time, right? 2 plus 10 is 12, plus 10 is 22. So it's arithmetic. And we're finding the sixth term. So that means you can rule out all these ones that have S, because those are sum. We're not finding the sum. You can rule out those. So it's either number 4 or number 6. So which is it? Is it number 4 or number 6 to find the sixth term of 2, 12, 22? There, I've narrowed it down to 2 for you. I've done most of your thinking for you. No hurry. We got 33 minutes left of class if we want to use it all. Sixth term of 2, 12, 22. Which formula are we using? Second one? Remember, we got it narrowed down to 2. You got this one or the one at the bottom. If we're finding the sixth term, it's none of these S's, because all the S's are finding the total. So it's really only number 4 or number 6. because that's the only ones that you're finding just the term. The others you're finding the sum. Find the sum, find the sum, find the sum. The sum is all those S's. So it's either 4 or 6. Danielle thinks 4. Jonathan thinks 4. All right. Well, we're going to put this up and look at it then more in depth because we need to, apparently. 6, 12, 22, and we went the 6th term. What's going on this? This is plus 6. Wait a minute. Plus 6. Oh, that wasn't 6, 12, 22. What it was 6th term. Fix that. I wrote it down wrong. The 6th term of 2, 12, 22. So it adds 10. It adds 10. 2, 12, 22. Adding 10 each time. So it'll go 32, etc. Plus 10. So this is a common difference. Common difference, which means our formula to find the 6th term has to be an A sub n. And somewhere in here, there's got to be a D because we use the common difference. Not an R because R is a ratio. This is a arithmetic, so it's got to be one that has a D in it. If we look at the choices, the 4th one uses the common ratio. We're not going to be able to use the common ratio to find an arithmetic. It's got to be the 6th one, A1 plus N minus 1 times D. Minus 1 times D. So if we go back here, A sub 6 equals 2 plus the common difference is 10 over here, and N minus 1 to be 5 times 10. So it's 52. 52 would be the 6th term. 1, 2, 3, 4. The next term would be 42. The next term would be 52. That is the 6th term. 2, 12, 22, 32, 42, 52. This is the formula. Right there. Now, fortunately, that only leaves one A sub n. So it should be only one of these that we're not finding the sum. It's this one. Find the 40th term. Well, that has to be that one. Now, all the rest of these are the sum. Sum. So let's look at the first one. Find the sum of the first 4 terms of a series that has a first term of 1, a 4th term of 7, and a common difference of 2. I wrote this terribly, but 4 terms. The first 4 terms. If we find the sum of 4 terms. They gave us the first term, they gave us the 4th term, and D2. So we have the first term, the last term, and the common difference. Which formula uses the first term, last term, and common difference? Well, this has a ratio. That doesn't work. That has a ratio. So n divided by 2, 2 times the first term, plus n minus 1 times the common difference. Or n divided by 2, A1 plus A sub n. It could be the first one. It could be the last one. These are both common ratios. So I wonder if either one of those will work. Well, since we have the last term, it's probably this one would be the easiest, right? We have the first term and the last term. Use the first term plus last term divided by the number of terms divided by 2. That's it. This one's find the sum of the first 100 terms. 1 plus 3 plus 5 plus 7. This one, we do not know the 100th term. But we do know it's arithmetic, right? It's adding 2. So it has a common difference. So 100 divided by 2 times 2 times 1 plus 99 times the common difference. Now we just have 2 geometric left. sum of the first four terms, first term, fourth term, common ratio. So this gives you the first and last term and the common ratio. So we should use the one that uses the first and last term. First term, last term. And this is another one. 2, 4, 8, 16. It's times 2. So we would use this formula here. All right, let's make this smaller. And they give you some more practice problems over here on page 4. What's the sum of a geometric sequence? -4, 24, -144. If there's 10 terms, you can check your answer. And there's 5 problems here. And that's all the practice they give you. Let's look at our lesson. I mean, not our lesson. Let's look at our assignment. Find the sum of this geometric sequence. 7 terms. The first 7 terms added together is what? How about an 8-term geometric sequence when the first term is 7, the last term is this? What does that up to be? I'm going to bet it's not 16,000 since the last term is 114. Why did we do that one as a practice problem? Evaluate S of 5. So the first 5 terms added together for 300, 150, 75. Which one of these? Just about a yo-yo company that rolls up by 60% of the original length each time. Wants to know the total after 10, the sum of this geometric sequence series right here. And finally, can you read the graph here? Oh, it's off the graph, so that's not going to help you. The diameter of a bacteria colony that doubles every hour. This will tell you the first term and all that kind of stuff. What's the diameter of the bacteria after 8 hours? So after 0 hours, it had a diameter of 1. After 1 hour, it had a diameter of 2. After 2 hours, it had a diameter of 4. After 3 hours, it had a diameter of 8. How big is the diameter after 8 hours? This is after 3 hours right here. 3 hours. They need 8. So you're adding the first 8 together there. So there you go. All right, guys. Geometric series. So again, 2 formulas. So we've done like 8 formulas in the last few weeks. We did arithmetic sequence, 2 formulas, series, 2 formulas, geometric sequence, and now geometric series. And hopefully you got all those in your notes. You'll have no problem as we get to the end of this semester in a couple of weeks. I mean, the end of this module in a couple of weeks. And have the final test on this because it's just plugging in the right formulas for the right type of sequence or series. So we're through with the lesson. I'm going to go ahead and dismiss class, and we will catch you. This is a B day Friday, so we have A day on Wednesday if you need any help. So give this a try before Wednesday. But unless your grade's over 70%, I won't see you again until next week, unless you want to come.